Dear students, now we will solve the exercise 4 from Mapa book, and all the questions are related to the polynomials. So here the first question in exercise 4. Question 1, 2. So find the remainder. Find the remainder when 2x to the power 5 plus x to the power 4 plus 2x cube plus x square plus 4x plus 3 is divided by 2x plus 1. Now how to solve this kind of problem? Here the solution. First you consider the polynomial as fx. So let fx equals to 2x to the power 5 plus x to the power 4 plus 2x cube plus x square plus 4x plus 3. Now the remainder, by remainder theorem, here we can write 2x plus 1, the trick, as k into x minus alpha. So that means 2x minus x plus of x plus half. So just to compare, what is alpha? Alpha is basically minus half. So by remainder theorem, the remainder when fx is divided by 2x plus 1 is equals to f of minus half. So that means 2 into minus half whole to the power 5 plus minus half whole to the power 4, 2 into minus half whole cube plus minus half whole square, 4 into minus half plus 3. And here the value is 1. So the answer, the remainder when 2x to the power 5 plus x to the power 4 plus 2x cube plus x square plus 4x plus 3 is divided by 2x plus 1 is 1. So this is our answer. Now we come to the problem. Problem number 2, 1. Find the quotient and remainder. Find the quotient and remainder when x to the power 6 plus x cube plus 1 is divided by x plus 1. So here it is asked quotient as well as remainder. We have to find both. So what we will do, we will apply the synthetic division. By the help of synthetic division, we can calculate easily the quotient and remainder. So what is our fx here? Let fx equals to x to the power 6 plus x cube plus 1 Now we apply synthetic division. And what is alpha? Alpha is just to think x minus alpha equals to x plus 1. So our alpha is basically minus 1. So then by synthetic, then we'll apply synthetic division. That process will apply. So here first we have the coefficient, x to the power 6 coefficient is 1, x to the power 5 is not present, so coefficient is 0, x to the power 4 is also not present, coefficient is 0, x cube coefficient is 1, x square not present, coefficient is 0, x is not present, 0, and then the constant term is 1. And here we write minus 1. So for synthetic division, you need to write 1 here. So 1 multiple minus 1, this is minus 1. We just add these two values, 0 minus 1. So that will be minus 1. And again, minus 1, 1. Just add this value, 1. So this is minus 1, and this value is 0, 0. Similarly here, 0, add 0 plus 0 is 0, 0, this is 1. So this part is basically remainder, and this is coefficient of quotient. So therefore the quotient is qx equals to, start backwards, so 0 plus 0 into x plus 0 into x square plus 1 into x cube minus 1 into x to the power 4 plus 1 into x to the power 5. So that is the quotient equals to x to the power 5 minus x to the power 4 plus x cube. This is our quotient. And what is the remainder? So here remainder is, that part is for remainder is 1. So in that way you can solve the second problem that is already done in part 2. Now we come to the problem number 3. Exercise 4. So here the first question, show that x to the power 20 plus x to the power 15, x to the power 10 plus x to the power 5, this polynomial is divisible by x square plus 1. So how to solve this kind of problem? So here, what is the polynomial? The polynomial f(x) is x to the power 20 plus x to the power 15 plus x to the power 10 plus x to the power 5. And also we have, so you need to show it is divisible by x square plus 1. So x square plus 1, that we can write x minus I into x plus I. So if we show x minus y is a factor of fx and x plus I is a factor of fx, that means I minus I are the root of fx. From that we can easily show this is a factor. So what we will do, we will obviously here I equals to root under minus 1. Here now first we calculate f of I. Actually that gives us x square plus 1 equals to 0, gives us x equals to plus minus I. So what is f5? I to the power 20 plus I to the power 15 plus I to the power 10 plus I to the power 5. So you know I is basically minus 1, I square is I is root under minus 1, I square is minus 1. So I cube is minus I, and I to the power 4 is 1. And you can say I to the power 4k is 1 for all n, for all k belongs to natural number. So now we can write I to the power 4 whole to the power 5, and that place we can write so I to the power 15, so I to the power 4 whole cube into I cube plus I to the power 4 whole square into I square plus I to the power 4 into I. So this is basically 1, and I cube is basically minus I. This is 1. So I square is minus 1 plus I. So this is exactly 0. So that means by factor theorem, since fi equals to 0, so x minus I is a factor of fx. Similarly, you will check f of minus y, and this is also 0. So that means x minus I is a factor of fx. Since x minus I and x plus I is a factor of fx, so the product from 1 and 2, therefore from 1 and 2, we say that x minus I into x plus I, that means x square plus 1 is a factor of fx. So thus it has been shown that we conclude that x to the power 20 plus x to the power 15 x to the power 10 plus x to the power 5 is divisible by x square plus 1. Now the second question here. Next question 3.2. Show that x to the power 20 plus x to the power 10 plus 1 is divisible by x square minus x plus 1. How to show? First we will find out the root of x square minus x plus 1. So x square minus x plus 1 equals to 0. So we can write here x minus omega x plus omega square. This is equals to 0, where omega is cube root of imaginary cube root of unity. So that means x equals to minus omega and minus omega square. So similar way, let fx equals to x to the power 20 plus x to the power 10 plus 1, and we have x square minus x plus 1, that we can write x plus omega into x plus omega square, where omega is an imaginary cube root of unity. What exactly means? That is omega cube equals to 1 and 1 plus omega square. This is 0. Now what we will do? So that means here the root are minus omega square. So now what we will do? We will calculate f of minus omega. So that means minus omega whole to the power 10 minus omega 20 whole to the power 10 plus 1. So we just calculate, you will get omega square plus omega plus 1. Since omega cube equals to 1. And this is basically 0 since 1 plus omega square. So that means minus omega is root. So by factor theorem, x minus or minus omega. So that means x plus omega is a factor of x. Similarly, again you will calculate f of minus omega square. So minus omega square whole to the power 20 minus omega square whole to the power 10 plus 1. So again you will see that will be omega to the power 40 plus omega 20 plus 1. So omega cube or 13 plus omega cube 6 into omega square plus 1. So that will be omega plus omega square plus 1 since omega cube equals to 1. This is again also 0 since 1 plus omega square is 0. So that means x plus omega square is also a factor of fx. So this is 2 and this is 1. And from 1 and 2 we can say, therefore from 1 and 2 we say that x plus omega into x plus omega square is a factor of fx, x to the power 20 plus x to the power 10 plus 1. So that means x square minus x plus 1 is a factor of fx equals to x to the power 20, x to the power 10 plus 1. So thus we have shown that x to the power 20 plus x to the power 10 plus 1 is divisible by x square minus x plus 1. Second we get the answer. So in similar way you will solve, this is your homework, question number 3 and 4 from Mapa book page 194. So this is your homework. I hope you will solve it easily in the similar way. Now we come to another important problem. This is question number 4.1. Express x to the power 5 minus 5 x to the power 4 plus 12x square minus 1 as a polynomial in x minus 1. That is one of the advantage of synthetic division. From synthetic division we can set up a polynomial in x as a polynomial in x minus alpha. So আমরা এটা ইজিলি করতেই পারি. So we come to the solution. So here what is our fx? Let fx equals to x to the power 5 minus 5x to the power 4 plus 12x square minus 1. And what is our alpha? What is our trick? X minus 1 equals to x minus alpha. So alpha is 1. Alpha equals to 1. Now we apply the synthetic division. First we write the coefficient of x to the power 5 is 1, then x to the power 4 coefficient x cube is not present. So coefficient is 0. Then x to the x square coefficient is 12. X is not present here, so coefficient is 0 and constant term is minus. And here we will write alpha, that means 1. So now what is the synthetic division? We write 1 here, 1 multiple 1. This will be minus 4. We just add minus 1, 5. Then minus 4. Again minus 4. That will be 8. Again 8. That will be 8. And 8 here, that will be 7. Again we apply synthetic division. So we write 1 here. So 1 plus minus 4 is minus 3. So this is minus 7. So 1. This is 9. Again in similar way you will solve this problem. So 1, this is minus 2, 1 minus 2, minus, this is minus 9, and 1 minus 9, this will be minus 8. Again you write 1 here. So 1 multiple 1, so this will be minus 1, and 1 minus 1, this will be minus 10. 1 is here, so 1 multiple 1, this is 0. So this is basically A0, we move backward, A1, A2, A3, A4, and this gives you A5. So here just consider, let fx equals to a0 plus a1 x minus 1 plus a2 x minus 1 whole square, a3 x minus 1 whole cube, a4 x minus 1 whole to the power 4. Highest degree is 5, so a5 x minus 1 whole to the power 5. Okay, so what we will write here? Okay, now this is a0, a0, this will be a1, this will be a2, a3, a4, a5. So by synthetic division, we can write fx. So what will be our fx? Fx will be a0 x minus 1. a0 is 1 into x minus 1 whole to the power 5. a1 is 0, x minus 1 whole to the power 4, minus 10 x minus 1 whole cube, minus 8 x minus 1 whole square, and 9 x minus 1 plus 7. So this is the required polynomial this is the required polynomial in x minus 1. So you, in similar way, this is your homework. In similar way, you can solve 4, 2 and 3. That type of problem we have done in the previous class. Now we come to the next problem, 5, question number 5. Question number 5. 1. Find the remainder. Find the remainder where x to the power 10 plus x to the power 7 plus x to the power 4 plus x cube plus 1 is divided by x square plus 1. So till now we have solved the problem. Find the remainder when a polynomial is divided by a linear polynomial. Now it is divided by quadratic polynomial. So here we have to solve with the help of division algorithm. So how we'll solve? So here let fx equals to x to the power 10 plus x to the power 7 plus x to the power 4 plus x cube plus 1, and we have x square plus 1 that can be written as x minus I into x plus I. What is I? I is basically root under minus 1. So here we assume that if we apply the remainder theorem, so that means if we divide the polynomial fx by x square, so this is our quotient and remainder. So if we apply this, so let qx be the, so it is divided, let qx be the quotient of fx, be the quotient of fx, and x plus b be the remainder of fx when it is divided by x square plus 1. So in that case, by division algorithm, we can write fx equals to x square plus 1 into qx plus the remainder rx. So what is the remainder? The remainder is x plus b. Why the remainder is x plus b? Because the degree of rx is less than degree of x square plus 1. So that means the degree of rx is either 0 or 1, and in that case it is rx is of the form x plus b. So this we can write fx equals to x minus I into x plus I qx plus ax plus b. So this is an identity in x. This is an identity in x. So we'll put I on the both sides and minus I on the both sides. So put x equals to I and minus I on the both sides of 1. What we will get? We will get fi equals to, that term is 0 if we put I here, ai plus b. ai plus b, and f of minus I, that will be a minus I plus b. Now if we calculate f of I, that will be I to the power 10 plus I to the power 7, I to the power 4, I cube plus 1. And by simple calculation, you will see this is 1 minus 2I. F of minus I to the power 10 minus I to the power 7 minus I to the power 4 minus I whole cube plus 1, and that will be 2I plus 1. How? As I square equals to minus 1, I cube equals to minus I, and I to the power 4 equals to 1. So from this we can write ai plus b. This is equals to 1 minus 2I, and minus ai plus b, that will be 2I plus 1. And if you solve this, so you will get the value is, from that you just add and subtract. In that case you will get the value of a equals to minus 2 and b equals to 1. So thus the remainder is x plus b minus 2x plus 1. This is our answer. In similar way, you can solve question 5, 2, 3, 4 and 5. Just you apply the same method, division algorithm, and you will solve it. Now we come to other important problem. So question number 8. Question number 8 from Mapa exercise 4. So if fx is a polynomial, if fx is a polynomial in x and a comma b are unequal, show that the remainder in the division of fx, in the division of fx by x minus a into x minus b is x minus b into fa minus x minus a into fb by a minus b. So how to solve this kind of problem? What is given? It is given fx is a polynomial in x. What are the information given? Fx is a polynomial in x and a comma ab are unequal, and we have to show that. What we have to show? We have to show that the remainder in the division of fx, by x minus a into x minus b is x minus b into fa minus x minus a into fb by a minus. That we have to show. So here fx is basically divided by x minus a into x minus b. This is a quadratic polynomial. If we apply the division algorithm, there will be quotient and remainder. So in that case, degree of the remainder, this is less than the degree of x minus a into x minus b, which is basically 2. So that means Rx is basically of the form x plus b, because degree of Rx is either 0 or 1. So by division algorithm, let the remainder be x plus b and the quotient be qx. So therefore by division algorithm, what we will write? We will write fx equals to qx into x minus a into x minus b plus rx. So rx is basically x plus b. Okay, so that means fx is x minus a into x minus b multiple some quotient plus x plus b. So this is basically, this is an identity in x. So that means if we put any value of x on the both sides, it remains the same. So put x equals to a, we get fa equals to, that will be 0, a plus b. This is 2, this is 1. And putting x equals to b in star, we get a for b, this is equals to ab plus b. Okay. So now what is, so here by 1 and 2 we get fa minus fb. This is equals to a minus b plus 0. What is the value of the constant a? A is basically fa minus fb by a minus b. Since a not equals to b, this is given, so a minus b is non-zero, so we can divide it. So we get the value of a. Now we have to find out the value of b. So putting the value of a in 1, we get fa equals to a plus b. So what is a capital A? This is fa minus fb by a minus b. And by simple calculation here you can find the value of b. This is basically fa minus a multiple fa minus fb by a minus b. So that means that will be afb minus bfa by a minus b. So we got the value of a and b. So therefore a is basically fa minus fb by a minus b. This is our a. And b is afb minus bfa by a minus b. This is b. So now we have to calculate the remainder. The remainder we have taken here. Ax plus b is the remainder. So the remainder is ax plus b. Now we put the value of a and b. So fa minus fb by a minus b multiple x plus afb minus bfa by a minus b. So now you will do the simple calculation and you will see it is fa into x minus b minus fb into x minus a by a minus b. So this is our answer. So we have shown that this is the remainder that is asked in the question paper. Now we come to the most important problem, one of the most important problem in this chapter, which has been asked in the final examination. So this is basically question number 10, very important. So if the question is, if the polynomial x to the power n minus qx to the power n minus m plus r has a factor of the form x minus alpha whole square, then show that q by n multiple n minus m whole to the power n, this is equals to r by m n minus m whole to the power m. So we will solve this problem now. So here it is given the polynomial has a factor. So what is given in the question paper? So the given information is the polynomial x to the power n minus q x to the power n minus m plus r has a factor of the form x minus alpha n whole square. So what exactly mean? That means alpha is a multiple root of order 2, or that is double root of fx equals to x to the power n minus q x to the power n minus m plus r. So in that case we can write f alpha equals to 0 and f dash alpha equals to 0. So now what is meaning of the f alpha equals to 0? That implies alpha to the power n minus q alpha to the power n minus n plus r equals to 0, and f dash alpha equals to 0. So now we need to calculate f dash x. So f dash x means n x to the power n minus 1 minus q n minus m x to the power n minus m minus 1. So that means n alpha to the power n minus 1 minus q n minus m alpha to the power n minus m minus 1 equals to 0. Okay, so this is equation 1, and here you will do the simple calculation. That implies you will take the common alpha to the power n minus 1. So this is our equation number 2. Now from equation 2, we have n alpha to the power n minus 1 minus q n minus m alpha to the power n minus m minus 1 equals to 0. So n alpha to the power n minus 1 q into n minus m alpha to the power n minus m minus 1. So in that case we can write, so alpha to the power m, this is equals to q by n into n minus m. This is 3. Just you cancel out by cancelling alpha to the power n minus 1 both sides. Okay, again from 1 we have alpha to the power n minus q alpha to the power n minus m plus r equals to 0. So here you just take the common alpha to the power n. So 1 minus q by alpha to the power m plus r equals to 0. So that means alpha to the power n and alpha to the power m, this value is So 1 minus q by n into n minus m plus r equals to 0. So this is by 3. So here you will get alpha to the power n 1 minus n by n minus m plus r equals to 0, and here alpha to the power n is r by m into n minus m. This is 4. Now we'll apply a trick that we have done earlier. One side is alpha m from 3 and other side is alpha m. How it will be equal? It is not equal in general. It will be equal if we take n here and n here. Now we just put the value alpha to the power n from 3. So that means q by n into n minus m whole to the power n. And alpha to the power n, that value here. So that alpha to the power n, that means r by m n minus m and whole to the power. So this is proved. So thank you.